Good morning, everyone. We're going to start soon at 9 o'clock. Okay, so let's begin our lecture for today. So this is the last part of the lecture for chapter 10, where what happened here is that we would like to discuss about the approximation, where we have approximations from normal distribution to, binomial distribution, approximate to normal distribution. So actually what happening here is that we are actually doing approximation of the case of a discrete distributions. We approximate to a case of continuous. And why we happen to do so and why we can do so is that, so recall back on chapter 9, when the time we discuss about discrete random variable, what we happen to know is that when the time you sketch the graph for the case of discrete, you happen to have something like this in your drawing, for example. Where, for example, I have the first line as x equals to 1, 2, 3, 4, 5. And then all this line here is happens to be referred to the probability for the corresponding x value. So this is what happened in discrete. And why I can have discrete approximate to continuous is that when, let's say, your discrete, instead of just having the data 1, 2, 3, 4, 5, you find out that your data have much more value, as I'm going to show you now. For example, instead of 5 bar there, instead of 5 straight line there, I have more straight lines involved. I have more straight line involved. So maybe there is 1,000, there is hundreds in my distribution. And by the time you look at this diagram here, you're as if like you see when the time you calculate, you try to calculate the probability, you're as if like referring as the regions of a graph inside the distributions. So as if like I can do this calculation using continuous to get the answer, rather than I consider discrete. Because for example, if let's say I want to calculate the probabilities from here to here, let's say involve of hundreds readings, I can't afford to do the calculation like x equals to 1 plus x equals to 2 until 100 is too much and it's not so efficient. So therefore, what we do here is that we try to find another way to solve this problem here. If let's say I want to find the probability for these 100 readings here, how I do is that I try to use the approximation approach where I consider this as the case of continuous. Then I just need to integrate based on the first and the last value. then I will know the probabilities for these parts here. Of course, the value may not be the exact value when the time we do approximations, but the value should be very close to the exact one, where maybe the difference is something that negligible, where the difference is by the 5th or 6th decimal places sometimes, which is very, very small. It's not so significant to be negligible. Okay, so this is the idea happening. And to have a clear cut points, that have a clear idea that when is the case that we're going to do approximation in our syllabus here, we happen to set 3 conditions to fulfill. The first one is that we want our n to be greater than 50, where this condition here happens to tell us that this is a sufficient large size that we're going to do approximation from binomial to normal. Then next, we want the probabilities from 0.1 to 0.9 only. We don't want to consider the probability too small. And lastly, I want to have NP greater than 5. So these are the 3 conditions that we need to fulfill in our syllabus. By the way, in some of the books, if you happen to refer, or in some system, maybe STPM or A levels, or some other thing else that is pre-U level, you find out that the condition of approximations here will be a bit different from us. For example, instead of having from 1 to 9, they maybe consider the condition that NQ greater than 5 as well. So this may be something that happens also, but again, in our syllabus, you stick to this thing here. You stick to this thing here. In fact, to make everything even simpler in our syllabus, but this is not a good way, a correct way to do interpretation. Saya sedang ajar you satu cara cepat, tapi sedikit ajaran sesat, where you sekadar dalam syllabus kita, you jumpa n greater than 500 saja for binomial, then you can start to consider normal approximation. Biasanya 2 condition belakang somehow will fulfill juga. Tak fulfill pun perlu ikut approximation sometimes. Okay, then go on. So therefore, from there, you'll find out that if I do approximation, to use normal, I need to know the mean and also the variance. And the way to get the means and variance, we just according to the calculations of mean and variance from the binomial distributions, where mu is equal to NP, where the mean is NP, the sigma squared with the variance is NPQ. Go on. Before we go on with the examples on how to solve questions for these approximations, you need to take notes. Whenever you do approximation, we need to do something we call as continuity corrections, where this is essential whenever you do conversions from discrete to continuous random variable. And you find out that the continuity corrections is always applied that using plus minus 0.5, and it must be done before you start standardization on your normal distribution. And here, before we go on with the examples, let us try to see why is necessary we need to do continuity corrections. So guys and girls, let's say I zoom into some particular value. For example, I just make it a simple value. Let's say I have 3, 4, 5. I zoom in the small part of the the binomial distributions. So this is happen to be the corresponding probabilities that I draw in brown line now. Okay. This happen to be the corresponding probabilities represented by discrete. So when the time you consider the case of approximations to normal, that means we are considering the area of the probability that we have. So when the time you're calculating probabilities for, let's say, x equals to 4, when the time you're calculating probability for x equals to 4, from binomial to normal, you're actually trying to calculate in such way that you're going to consider the probability line of 4, instead of it is happen to be a line, we consider it's happen to be a bar. Like what I'm doing now, I construct a bar for x equals to 4. And now the shaded regions for the bar will be the approximation we're referring for the probability for x equals to 4. And in order to make this bar here happen to be systematic and consistent for each of the x value that we have, what we're going to do is that we make the gap between the two consecutive value here, we make this point here as the midpoint of the two consecutive value. So 3 and 4, here will be 3.5. And the 3.5 apparently as if like we have 4 minus 0.5 or 3 plus 0.5. So this is the idea how come you see the corrections you have plus minus 0.5, because you want to find this border here. We want to find this border here. Okay, now without further ado, let us refer to example 1. So this is the example 1 that I want to refer. There's a lot of example 1 in your lecture notes. So I want you to refer to this example 1. In your lecture notes, they happen to show you like more examples with diagram as well as solution, how to decide the continuity correction. But in here, I'm not going to refer that, but we just direct go to example 1 that as you see in the screen here, the 6 sub questions here. Sorry, the 8 sub questions here. And we begin to learn how to do continuity corrections for each of the case, according to the idea I'm going to deliver to you. So let's see, how am I going to do continuity corrections? If let's say without memorizing the whatever formula that you can see in the slide or in the books, we just use common sense interpretation in the way that, okay, so first of all, you see in these inequalities here, x less than or equals to 5, the value you see is 5. The value you see is 5. And the inequality have equal sign. So what did they tell us here is that when the time you consider your continuity corrections, you must include 5. And let us begin with the frame of the continuity corrections. So the frame will happen to be just as simple as we copy back the x, we copy back the 5, the inequality sign, we copy back. But remember, the continuity corrections, we just make sure that there's no equal sign. So, sorry, I made a mistake here. The 5 should not insert yet. I should insert the sign first, less than. Okay, now, I need to include 5 in this less than symbol here. And how can I happen to get the answer? So, use a number line and mark down the 5 here. And we know continuity correction is either we consider 4.5 or we consider the case of 5.5. And what you want now is that you want to make use of the symbol less than. So less than for 4.5, it will happen to be in this form. 5.5, it will happen in this form. And now we want to see, you want to cover, you want to include 5 or not, and which of them is happen to be the one that include 5 or not include 5. So in this case here, you want to have equal 5. So you want to include 5. In order to include 5, the number line that you can see that it cover 5 will be happen to be, you want to cover 5, so it will be 5.5 as the answer here. Again, the number line is not a compulsory step, it's just a simple guideline for us to know whether we need to consider which value. Go on. Next, for x greater than 8, so without hesitations, we just copy down the p and x, inequality sign, use the same direction, and without equal, continuity correction, always we do without equal. Then once again, As a beginner, we consider in such that, let's say I have 8, and in this case here, I don't want 8, saya tak mau 8. So, and I want for the case of greater. So, which are the case of greater that I can I can draw the number line without go through 8. So, this is the borderline for 8. If I want to draw a number line of greater, and my choice is 7.5, my choice is 8.5. If I draw for 7.5, it will go across 8. So this is not something I want. If I draw greater for 8.5, it doesn't go across 8, it doesn't include 8. So therefore, our answer is greater than 8.5. That's it, the idea that you can see. Of course, some of you may able to just visualize by inspection. By looking at the value, you know whether you need plus or minus 0.5. But once again, in here, I'm trying to do the beginner way. So follow px less than 10. So once again, 10. I have the choice of 10.5 and 9.5, and I don't want to include 10. So if I don't want to include 10, 9.5, 10.5. Less than 9.5 and less than 10.5. If I don't want to include 10, that means when the time I draw the less than number line, it won't cross this dotted line. So the case will obviously for 9.5 as the answer. Go on. For the case of greater equal 125, so the approximation will be x greater than, again, no equal sign. So greater than 125. So again, 125. I either choose 125 minus 0.5 will give me 124.5. The other one is 125.5. Greater than or equals to 125. I need to include 125. So if I want to include 125, so it's very obvious that this is the number line that I'm choosing, where I'm going to have greater than 124.5. Okay, from A to D, it should be considered a case that quite simple because involved of considering of one value in inequalities only. Now, starting from E, F, and also G, I need to consider two values there. So please alert and take notes whether how we determine the answer. So next one. By the time I want to consider for from 3 to 9. So again, first your framework will be inequality, same direction, but without equal sign. And what value that we should have here? Again, as a beginner, let us think in this way here. So I have a borderline of 3 and 9. I want to include 3. I want to include 9. So from these readings here, you can somehow see that this part here is actually referred to x greater equals to 3. So I want to draw a number line in such that I need to draw a greater and also include 3. And my choice, I have 2.5 and 3.5. If I draw a greater number line, the one that include 3 will be 2.5. Dia akan cover 3. So I know I need here as 2.5. On the other hand, if I want to have include 9, and I'm considering the case of x less than, so I'm going to draw a less than number line there. What I will have is that I will have 9.5 so that I can cover 9. So in here, I will have 9.5. Lastly, F and G. So again, inequality sign without equal. Then 2 to 7, again, we try to observe from number line. 2 to 7. I want to include 2. I don't want to include 7. So for the case of 2, I'm going to have x greater equals to 2. So draw a greater number line so that I can include 2. So greater include 2, it will happen to be this one. So here will be 1.5. I have 1.5 less than x, less than equal. Then 7, I don't want to include 7. So I should draw the number line less than on the left of 7. And this part here will refer to 6.5. So it gives me the result 6.5. G. So G, I have 0 to 4. And this time, let us try to 1 times by inspection. Kita without drawing the number line, kita cuba tengok-tengok. Boleh tak kita dapat jawapan? So again, inequality sign same direction, but without equal sign. Your continuity correction, the CC, please always make sure no equal sign. No matter what, no equal sign. And now we try to do this by inspection. Whether this position here, shall we choose negative 0.5 or shall we choose 0.5? So in here, by inspection, I notice that I need to choose 0.5. So why I want to choose 0.5? Because this is a discrete case where if not include 0, so the next value will be 1 and so on. So the value start from 1. So how can I start the value from 1? For the choice of negative 0.5 and 0.5, so my choice will be, I have here 0.5, so that the next value is 1. If let's say you happen to have negative 0.5 as your choice, then your first value of your x will be 0, but we don't want 0 in this case here. Then lastly, 4. I don't want to include 4, so if I don't want to include 4, the value before, the integer before 4 will be 3. So in this case here, my choice will be using 3.5. So that again, you check your quantity corrections, and also before quantity corrections, you shall able to see that there is somehow by discrete, they happen to have the same list of x value. Lastly, when the time we have equal, looks so simple, but when the time we want to do quantity corrections, how we get the answer? So let's see. 32. To get the answer for 32, again, this one I need to see in another point of view. This one as if I am referring to the probability of this straight line here. And since we are doing approximation, instead of referring to this straight line here, we're going to turn this straight line here into a bar, where the bar is constructed from 31.5, which is 32 minus 0.5, and 32.5, which is 32 plus 0.5. From here to here, plus 0.5, the other side, minus 0.5. So we are referring to the regions of this bar here, and therefore, your probability, it is referring to 31.5 less than x, less than equals to 32.5. There goes your answer. So this is somehow the rough idea on how we learn to do continuity corrections. Then in the next examples, I won't spend too much time to explain about continuity corrections anymore, but I will direct go for how to solve the questions. Let's see the procedure on how to solve the question number 2. Just a straightforward examples that we need to do approximations from binomial to normal. So let's Let's see, we have X followed binomial distribution. The N is 200 and the probability 0.3. Use normal approximation to find. So in these questions here, you don't have to check any more the condition because the questions already give you the instruction, use normal approximation. If the question happen to have instruction asks you to use normal approximation, then you don't even need to bother whether the condition is fulfilled or not. Kalau dia minta, ikut saja arahan dia. Kalau dia tak minta, then kita perlu observe lah sendiri. Adakah ada keperluan? So therefore, in this case here, what we're going to do is that from binomial distributions, 200 to 0.3, 200 at 0.3, we know that we want to do approximations. So therefore, we just calculate what is the normal distributions, the mean for the normal distribution. 200 multiply 0.3 for the mu, n times p. So we have the result equals to 60. Followed by the variance, we have NPQ, 200 multiply 0.3 multiply 0.7. The answer will be 42. So as a result now, you happen to have your X now follow normal distribution such that mu 60, sigma square 42. So you happen to have done the approximation from this one to the following. Okay, next. A. We have our X less than 50. So we want to find the probability. Now, not just stop at continuity corrections. We want to find the probability for this case here. So A, if I have the case of X less than equals to 50, so guys and girls, take notes. You must first begin with your continuity corrections. So we will have X less than. So in the case of 50, you have the choice of plus 0.5 and minus 0.5. Plus 0.5 will be 50.5, minus will be 49.5. And our choice here, if I want to have include 50, then my choice will be less than 50.5. And then once I've done my continuity corrections, I will have my standardizations. So I have Z less than 50.5 50.5 minus 60 divided by square root of 42. Remark again, this is actually referred to sigma square, and what you need here, you need sigma only. Sigma is square root of 42. And here, let me highlight one thing here, where there is referred to the continuity corrections. I just write short form CC. Of course, in exam, your solution, you don't have to write something like this, but I just need you to be alert. Go on. I will have Z less than. So when the time you calculate for this part here, you just need to keep your answer correct up to 2 decimal places will be good enough, because your statistical table, we only can get the answer based on 2 decimal places. So by 2 decimal places, I will have Z less than negative 1.47. And once again, once I done my standardization, if let's say I have no idea how to proceed, always confirm from a bell-shaped diagram. Middle is 0. Negative 1.47, somewhere on the left of 0. The region is referred to less than, so this is the one I shaded in red. Then next, regions on the left is not something that we can find from the statistical table. So we consider the equivalent regions on the right, and the corresponding value I have here will be 1.47. Opposite sign of negative 1.47. So the region in blue, you will somehow find out that it is happen to be called as Z greater than 1.47. Again, have equal or not doesn't matter in this case here, because for your statistical table, it apply for both of them, with or without equal sign, because it is a continuous case. So from statistical table, Z greater than 1.47, we have 0.0708. Okay, then we proceed for part B. So what we have for part B now is that we would like to calculate the probabilities Okay, so for part B, we would like to calculate the probabilities x greater than 60 and for px greater than 60. So again, the first step we do is that we try to do continuity corrections, where again, I have x greater, same directions, and without equal sign for continuity corrections. So 60, my choice here, I want to have either 60.5 or 59.5, plus minus 0.5 for 60, for the choice of continuity corrections. And in this case here, I don't want to include 60. So my choice will be taking 60.5. So that you will see that in this list here, you find out that it doesn't include 60. So this is a step that I highlight for CC, continuity corrections. Then go on. Next, what we have for our calculation is that we go for standardization. We're going to turn x become z, where z is greater than 60.5, 60.5 minus 60 divided by square root of 42. And as a result, when the time you do the calculation, you have z greater than. So once again, keep your answer into two decimal places. We have 0.08 as the result. And up to here, once again, you can double confirm with your bell-shaped diagram to see whether can we solve this directly from the table. So middle is 0, 0.08 somewhere here. So there goes the regions. And these regions, you can see is small and on the right. So we can direct from table. And you find out that the answer, I have P z greater than 0.08 is equals to 0.4681 from the table. Then we proceed. Question C. I have P 36 less than equals to X less than equals to 54. So be careful. Before you're so excited to do standardization to solve these questions here, let us do continuity corrections. So again, the inequality sign, same directions, but without equal. And we want to consider the case that I want to include 36, I want to include 54. So let us use a number line to have a quick check. So in order to cover 36 and 54, I will consider the coverage as follow, where I consider somewhere on the left of 36, which gives me 35.5, somewhere on the right of 54, which gives me 54.5. So as a result, I will have 35.5 less than X less than 54.5. So again, this step I highlighted is referred to the CC, continuity corrections. Next, what you do is that we do standardizations. So standardization occur when the time your X return becomes Z. And how the turning is being done is that we take the value in here, 35.5. We minus with the mean in the questions here. Okay, sorry, I don't have enough space, so let me erase it and write it slowly. Okay, so I have P 35.5 minus 60 divided by square root of 42 less than X turn out becomes Z, then 54.5 minus 60 divided by square root of 42. Then we press the calculator, convert into 2 decimal places. We have answer as negative 1.16 less than Z less than negative 0.23. Come up to here. How we happen to get the answer for this interval here for Z? So again, we consider the bell-shaped diagram. Middle is 0. Negative 1.16 and also negative 0.23. The location will be somewhere on the left of your 0. Where I find out that I have negative 1.16 and negative 0.23 in such position as comparison. And here will happen to be the regions I want to find. So once again, the region is happened on the left. It's not something that we can find from table. So what we do is that we convert it to the right regions, where now the regions in blue on the right, we have the interval from 0.23 and also 1.16. This is the regions in blue. And therefore, from there, somehow we notice that now I can happens to have the P turn out to become 0.23 less than Z less than 1.16. Then go on from here. If I refer to the regions in black, the regions in blue, what I happen to find out that in order to calculate the regions in blue, I can consider the regions that I highlighted in yellow all the way from 0.23 until infinity. minus the regions now I try to shade in purple, this part here, where the region I shade in purple will be the regions from 1.16 until infinity. So from there, we find out that we can have the result as P Z greater than 0.23 minus P Z greater than 1.16, where this is happen to be the purple regions. The other one will be the regions in yellow. When you minus them, you happen to get the answer for the region in blue. And now refer to statistical table. You have the answer 0.4090 minus 0.123. As a result, I have 0.2860. So that goes the answer for D. Proceed. E. What we want for E is that we will have P 66 less than X less than 76. And once again, before we go for standardization, again, we need to consider the CC, continuity corrections. So have a quick look on the continuity corrections. From 66 until 76, we don't want 66, we don't want 76. So that means I will consider the interval somewhere inside here, somewhere on the left of 66 until, sorry, somewhere on the right of 66 and somewhere on the left of 76. And the somewhere and somewhere here will be 66.5 and the other one will be 75.5. Sorry, I think I refer to the wrong questions. I salin soalan salah. By right, this one is not less than. This one's supposed to be less than equal. So if let's say less than and less than equal, let me consider again the situations. Continuity correction still the same, less than and less than. No, the sign ignore. The sign equal is ignore here for continuity corrections. So I want to have 66, 76 on the number line. I want to not include 66, but include 76. So what happened is that I should consider the interval somewhere on the left, sorry, somewhere on the right of 66 until somewhere on the right of 76. So that I do cover 76 and exclude 66. As a result, here is 66.5. The other one will be 76.5. Then proceed. Now, again, let me highlight in yellow. And then now we can proceed with standardizations. So by standardizations, I will have X term becomes Z, X term becomes Z, and the value 66.5 will be minus the mean 60 divided by the standard deviation square root of 42. Similarly, 76.5 minus 60 divided by square root of 42. And as a result now, simplify our answer into two decimal places. we find out that the first answer in front will be 1.00 less than z less than 2.55. So once again, we check with number line. So middle is 0. Here is 1. The other one is 2.55. The regions will be somewhere I shaded in red now. And in order to get the region in red, what I do is that I consider the regions in green, which is from 1 until infinity, the probability from 1 until infinity, minus the regions in purple, which is from 2 to 2.55 to infinities. So as a result, to get the region shaded in red, I have probability, the one in green, z greater than 1.00. This is the region in green, minus probability, z greater than 2.55, the region in purple. And as a result now, we substitute our, As a result, now we substitute the value according to what we can obtain from statistical table. So greater than 1, it gives us 0.1587. Minus, for the case of P 2.55, from statistical table, we get 0.00539. And by the time we minus the answer, we get about 0.1533 if we correct to 4 decimal places. Then the last one in example number 2 here, the F, we would like to have Px equals to 70. So in this case here, 70, it will be a single value in between the case of 70 plus 0.5 and minus 0.5. So minus 0.5 will be 69.5. The other side will 70.5. So once again, what happened here is that we do continuity corrections. Then we follow by standardization. We take 69.5 minus the mean 60, divide by standard deviation. X term becomes Z. 70.5 minus 60, divide by square root of 42. Simplify your result. You may be able to find out that you have 1.47, sorry, less than Z, less than 1.62. Then from there, again, have a quick look on the bell-shaped diagram. 0. So we have 1.47, 1.62, again, 1.47, 1.62. So the region I want is this one, shaded in red. In order to get the answer, what I do is that I consider this part, whole thing here, highlighted in green, where the highlighted in green, it gives us pz greater than 1.47 v minus. So this is the part highlighted in green. V minus the part that I'm going to highlight in purple. The part that I highlight in purple, which happens to be the probability for z greater than 1.62. And as a result from statistical table, we find out we have 0.0708 minus 0.0526. And as a result, I have 0.0182. There goes your answer. Okay, finally, we go for the last examples in approximations, where we have some real-life situations to discuss about this. The next example is still stated as example 1, but let us correct it, become example 3, which is discussed about a fair coin is tossed 400 times. Find the probability that getting A less than 230 tails, between 180s and 190 tails. So in this case here, we need to interpret the whole situations into whichever distributions and random variable that is related. So first of all, we need to identify what are the events that we want to discuss here and what is happening in here. You was told that we're having the experiment of a fair coin is tossed, and we would like to find out the probability of getting the number, how many times you get tails. So in this case here, I notice that I will have my x, the random variable x, I will define it as the random variable x, I will define it as the number of tails obtained, because all this while we are discussing how many tails is obtained, and I notice that my x will happen to be follow binomial distributions, where I have 400 times of trial, and the probabilities of getting tails in this case here will be 0.5. The chances is 50%, because it was told that it's a fair coin. So whether head or tails, I have equal chances to obtain it. And now when the time you look at these probabilities, this distribution, these binomial distributions, you see the n is 400, the probabilities 0.5. So the moment you notice that your n is greater than 50, we can start to suspect that we need to use approximation to solve these questions here. So if you suspect to use approximations to solve the question, let us try to calculate out what is the corresponding value for the mu, which is NP. So we have 400 multiplied 0.5. If it happens to give us the answer equals to, so in here, I will find out that my answer is equals to, how much is it? 200. So guys and girls, 200. Therefore, this is obviously greater than 5. And of course, there's another details we need to take notes lah, where the n is equals to 400, which is greater than 50. But you see, I use orange, not red. Orange color pen to write here. This is not a compulsory step to write down lah, but just for you to take notes. Ini untuk you take notes saja. Tak payah tulis keluar. Then the probabilities also, when the time you notice, the probabilities 0.5 is happen to between 0.1 and also 0.9. This is actually your P. So we need to use approximation, and the approximation tells us that the mu is NP, which is 200. The sigma square will be, we have our NPQ, 400 multiply 0.5, multiply with 0.5 again. So we have the answer as 100. So as a result from our calculations here, we notice that my X now, by approximation, it will follow normal distribution such that I have mu as 200, sigma square as 100. So sigma square 100, maybe I will suggest that 100, we can rewrite it in the form of 10 square. So that easier for our writing just now, where we want to use the sigma, which is 10. Once you're done with this thing here, again, be aware of this approximation. This is, be aware of this distribution, which is what we're going to use later for further calculations. Okay, then go on now. Part A. What I would like to find out is that I would like to find out the probability that I have less than 230 tails. So just now we say X is the number of tails. If I have X less than 230, that means I want to get probability less than 230 tails. That means I have X less than 230. Then once I get these probabilities, this probability stated, next thing we try to calculate out the value, and please be aware, I'm going to begin with continuity correction first, because this is an approximation from binomial to normal, from discrete to continuous. So X will be less than 230 here will be correct too. So I don't want to include 230. So my choice will happen to be 229.5 less than 229.5. So this is the result of my continuity corrections. I will have X less than 229.5. So sorry, we have 229.5. And once again, let me highlight this one. So this is actually the continuity corrections that we have done. Then we go on with the calculations. Our calculation, I will continue with standardizations. So I have Z less than 229.5 b minus 200 divided by 10. Follow the result, we're going to write it in 2 decimal places. I have Z less than 2.95. So with the result of the standardizations, again, we have a quick check. We have a quick check that whether, in this case here, in the bell-shaped diagram, where is the regions that involve. So I will have the bell-shaped diagrams. Middle is 0. 2.95, somewhere on the right of 0. And the region I want is this one. And in order to get the regions in red there, what we can do is that we apply the idea of 1 minus. So 1 minus will be minusing the parts that we don't want. So which is the part that we don't want? It will be this part here now. I highlighted in purple. So we have 1 minus 1 minus 1 minus this part I highlighted in purple, and the part there, it is actually equivalent to Pz greater equals to 2.95. And based from statistical table, Z greater than 2.95, I will have the answer as 0.00159. And as we calculate the subtractions, we have the answer correct to 4 decimal places as 0.9984. Followed by the last examples. Probability getting between 180 and 190 tails. So 180 and 190 tails. Take notes, in this case here, I want between, therefore inequality sign, no equal. So next, before I go for standardizations, I need to do continuity corrections. I need to do continuity corrections, where in continuity corrections, what I will have is that, let's see again, let us have a quick look. What are the coverage that we need here? So let's see. Here is 180, here is 190. I want between them, so that means I consider somewhere within here. Where this part here, I will consider 180.5. The other side, I will have 189.5. So as a result, now I have 180.5 to 189.5 as the interval. Next, before I go on further, again, I highlight this part here to as a remark of continuity corrections. Then next, I will go on with the standardization. Now our x return becomes z, where here I have 180.5 minus 200, the mean that we calculate just now, divided by sigma 10. 189.5 minus 200 divided by 10. Then as a result, I have my probabilities 1.05 less than z, less than, sorry, wrong calculations. Negative 1.95 less than z, less than negative 1.05. And again, you can try to check from bell-shaped diagram to see the regions. You find out that the regions is the part that I shaded in red, where I have negative 1.95 to 1.05. And these regions here, I have a corresponding regions on the right, where it will happen to be 1.00 until 1.95. And in order to get the answer for these situations here, I will have P, Z, I will have my PZ written as 1.05. Sorry, this one is 1.05. 1.05 less than Z less than 1.95. And for the calculation in these situations, it will be happen to be Pz greater than 1.05 minus Pz greater than 1.95. And once again, let us revise how I get these regions here. The regions is obtained by considering the regions that I highlighted in green all the way from 1.05 until infinity. So this is the region in green minus the region in purple behind here, which is from 1.95 until infinity. Then from statistical table, we obtain our answer. We have 0.1469 minus 0.0256, and as a result, 0.1213 as the answer. Okay, with that, I have finished the last examples of the lecture notes. And the next hour, face-to-face class on Monday, I will continue with the discussions on whichever exercise that is not discussed in our lecture notes for chapter 9 and 10. And I think I will begin with the exercise for chapter 10 first, since maybe you're still fresh in your mind what is going on. Then I will follow with the undone exercise in chapter 9. And then the rest of it, if there is any more exercise that for the exam chapters have exercise that is not complete, then I will do that as well lah, the discussion for lecture. So for next week, lecture masih jalan seperti biasa, no matter for Monday, Wednesday, Friday or Saturday. So please make sure you attend the class. That's all for today. Thank you very much. Question D. Wait a minute. What is the question D missing? Question number 2, I'm missing question D. B, C. Oh, sorry. Belum habis lagi. I tertinggal satu soalan. Refer back to example number 2. Example number 2. Question D. Saya tertinggal soalan ini, baru sedar. So just rewrite back lah the distribution that involved here. So we have X follow normal distribution 60, 42. And for question D, I would like to find out the probabilities for 52 less than X less than 59. And how can I get this answer here? So again, we have a quick check on number line. So let's say here is 52, here is 59. I don't want include 52, I don't want include 59. So I will consider somewhere here on the left, on the right of 52, on the left of 59, which give me 52.5 and also 58.5. So therefore now your interval from continuity corrections, it will be 52.5 less than X less than 58.5. So this is the continuity corrections. Next, what we do is that we proceed with standardizations. By standardizations, we happen to have 52.5 minus 60 divided by square root of 42. X turn to become Z. Then 58.5 minus 52.5 divided by square root of 42. And as a result, what we have here from our calculation, I happen to find out I have the answer as negative 1.16 less than z less than negative 0.23. So have a quick check. The regions will happen to be somewhere like this. Negative 0.2, salah. Negative will be somewhere on the left of 0. So again, so have a quick check on bell-shaped diagram. Middle is 0. So I have negative 1.16 and also negative 0.23. This is the regions. The regions on the left, I cannot use statistical table to help me. So I consider the regions on the right, where I will have it from 0.23 until 1.16. The way to calculate these regions in blue, which is denoted as P, 0.23 less than Z less than 1.16, you can calculate in such that I consider the part now I highlighted in yellow minus the part now I highlighted in purple. So the part that I highlighted in yellow, if it happens to be probability Z greater than 0.23, the one in purple, Z greater than 1.16. So this is the probability for yellow, probability for purple. And based on the result I happen to have from table, I find out that I have 0.4090 minus 0.1230, and it gives me the answer as 0.2860. So this is the answer for question D. Okay. Hopefully there's nothing else missed out. Okay, so this is the solution for question D. And I think that's it. Good. Thank you very much for Muazzin that you find out that. Okay. So that's all. Thank you very much.